Welcome to the Flare Build Podcast. Today's guest is Maxwell Elliott from Tinder. Maxwell is an iOS engineer at Tinder and is a member of the iOS Developer Experience team. He's the author of Bazel-Diff, a target selection algorithm for Bazel, allowing users to build and test the exact set of change targets between Git revisions. When not coding, he loves spending time with his family and friends. Now, over to your hosts, Zach and Tatiana, the co-founders of Flare Build, the first consultancy and product-based company focused on Bazel.
Welcome back to the Bazel Show, and today we're talking about Bazel-Diff, and we're here with the creator, Maxwell Elliott, and I'm just going to go ahead and hand it right over to Maxwell to give the intro, the pitch here for this tool.
Great to be here today. I'm Maxwell Elliott. I'm a software engineer at Tinder, and I'd love to talk to you all about Bazel-Diff. Bazel-Diff is a target selection algorithm that we use at Tinder to select and build only impacted targets in CI and CD. And it's completely open source and available for the Bazel community to use.
Yeah, I think the question which obviously arises right away is like, why did you write it? What was the motivation behind it?
Exactly. So that's a great question. So Tinder was kind of a moment where we in CI were facing a lot of issues with our stability, in our tests, and then a lot of issues with execution time. We found that we had one target that took up most of our time. We were running lots of tests in CI that had nothing to do with a change, right? So we'd have a flaky test, and that's a problem in itself, but so many times that test wasn't even impacted, right? Like that test was not related to this change at all. And we really thought, how can we continue to scale? We knew we wanted to add more tests, but how can we get to a place where, and there's always going to be flaky tests, right? You can't promise a test won't be flaky. It's like really the effective way is to run less tests. And so during this time, we came across this 2018 BazelConf talk called Testing Velocity. Mm-hmm. And this talk, basically spoke to what we were looking to do, which was increase testing, but not have a exponential growth in our defect, our number of failed builds and flakiness and our testing time. We didn't want that. So we started investigating at the time into Bazel. Obviously, we kind of had something working, but then we wanted to put our best foot forward. Like during this effort, we didn't want to just say, we've deployed Bazel, like this is done. We wanted to lock in gains from the very beginning. And so we watched the lift talk from Key Smiley when he talked about target selection. I know he kind of, at the end, he talks about query. He used a little bit of query. I think that's kind of what they maybe still do today. They use kind of an advanced query to tell them what happened. And we did something like that to start, like a little bit of query, but we ran into lots of issues. BZL renames, BZL deletes, deleting files, adding files. Certain things would happen that were unstable. So right around when we're at this phase of this work, in this investigation, we came across Benjamin Peterson's talk about selective testing, the BazelCon 2019 event, and seeing these queries, seeing these different options, I was really struck immediately by what Benjamin was saying. He's using cryptography, using this elegant Merkle tree kind of attempt of taking a target and cryptographically determining what that target is, depending on its attributes, its implementation, and everything. Everything goes into that rule. So it's implementation, then all of its attributes, its files, and all these things. I loved it. I've watched the talk so many times because I just thought it was a great solution. And basically, there was no open source solution, but still available. At this point, Benjamin did a great job telling through how this could be done. At the end, there was kind of some talk. At the end of that talk was, is there going to be open source? And kind of Benjamin was back and forth of, maybe, maybe not. And it just didn't come to fruition. And I don't blame him. I feel like some of these systems are bound a little bit into their CI systems, especially if they've grown inside their CI system. And so I realized that at that point, I was like, okay, we want target selection. Let's just build this open source from the beginning. There's so much need in the community. I was coming across GitHub issues that were just tons of CI, build engineers were talking about like, this has to be solvable. And I would hear an engineer like Uber say, it is solvable. Like we've done it. And, all these different engineers were saying, we've done it. And I was like, let's just do this and share it with the community because I'm learning about Bazel. I think I have an idea to fix it, but what's even better is to have the open community also fix it and like say, hey, oh, this attribute's missed, or there's a new key in Bazel 6, right? We also need to like integrate that in versus us being like, oh, whoops, there's like a new key. It's like we have a lot of companies helping us do it. So yeah, kind of like the impetus of BazelDiff.
Yeah. So I guess, for people that aren't familiar with, this problem space, I guess the first naive question is, why can't I just use a wild star and just say Bazel build or Bazel test like ...
Yeah, so Bazel, there's a couple parts of that. Benjamin covers some of it in his talk. And so first off, when you do Bazel test ... // ... Bazel needs to construct basically all of the arguments that go into every single action have to be constructed, right? So that's part of creating the structured command line. You'll see it in the BEP. All of these need to be created, right? So for your whole graph, all of those still need to be created. And then those will go into the actual determining if this action is being clear or not. But then even if that's determined, if that action wasn't cached locally, you still need to go to your server, right? So you're basically, you're hitting your cache server pretty hard, right? Like you're hitting your server and saying like, here's all these things. Even though I could figure out that most of the things were impacted, I'm just going to say like, hey, go figure out that everything's impacted. Construct all the command lines. It takes a bunch of memory. That takes a bunch of CPU to figure out. You have to do a lot of analysis in that phase, hit your cache server. If you have a really healthy cache, if you have everything's really performant, I mean, sometimes these problems could be, less valuable, but we found with selection that it's just so precise. It's like, why not use that approach every time? And actually, there's other benefits we've seen of tracking. We actually track every single time a target's impacted. So we understand in our graph which targets are like a good candidate for being either combined or removed, or like these tests are just not engaged that often. These tests are engaged like once every blue moon. It's like, what are these tests doing? Like, can we evaluate our graph a little better? Because we know every single time this is happening, or every single time what targets are getting hit. So yeah, basically Bazel is very smart, right? Bazel is able to do everything that BazelDiff does, obviously, because you can run Bazel tests. But it's so awesome that this technology lets you do less and lets you figure out exactly what happened. So
yeah, I want to drill a little bit in on the analysis stuff because I think that's an important thing. Like in my mind, the main issue with using like ... is at truly huge scale with millions and millions of lines of code. It's pretty much prohibitively expensive to do just the loading and analysis phase across like an entire, like a true mono repo, right? Like that'll take hours before we even get to maybe even doing no work, right? And so that's a thing that I think a lot of people sort of overlook because we know that Bazel, of course, is going to be doing incremental builds. So we feel like, okay, like naively, we can just build ... And if there's nothing to build, it won't do anything. But that's actually not really the case. Because we still suffer the loading and analysis phase. Yeah. So that's, I think, a great overview. So the motivation is really Bazel, even though it's good at incrementality, it doesn't really have like an outside sort of interface for a tool or a developer to truly targeted, like do targeted builds of things that are actually changed, right? And so like that's the motivation. Maybe let's talk about how you went about beginning to design and implement this. Obviously heavily informed by, the prior work from other folks, but what did it look like jumping into the prototyping phase here?
Yeah. So first off, I was really shy, but I reached out to Benjamin. I was like, hey, Benjamin, it sounds like these protobufs were used to determine this calculation. Like, I didn't even know what protobuf was, like I didn't know Bazel super well, but I was learning it. I knew like how to build a couple things, but I didn't know deep the BEP yet or like how the BEP worked. And he's like, oh, here it is. He just sent me like the link to the proto file and that was it. And that's really all I needed. So took that file and I started first off, I wrote this first in Swift. So because that's the language I'm most familiar with, because I'm an iOS engineer, kind of Apple engineer, I guess. So started with Swift and I kind of hit a roadblock there because I knew that Ulf had talked about gigabyte large protobufs, right? So you talked about these idea of incredibly large protobuf files. I wanted that to work really well out of the box. And I knew that there were some proposals in Swift of like how you could do it, but at the time with the proto libraries that were provided, it was still kind of unclear to me how I would easily parse like a stream from that proto. So started with that and then I hit a wall. So I was like, I can't read, like at the time, I couldn't really quickly figure out how to read that gigabyte. Then I went to Go. I tried to write in Go. Kind of hit the same problem in Go. I was like, how am I going to just easily consume a file and like parse delimited from it, right? Easily in like a stream, regardless of how big it is. And then I landed on Java. And so I landed on Java. The protobuf client had, an easy to use parse delimited from method. And it was fine. I've written Java in the past. So I was like, okay, here we go. Like, let's start writing some Java. I saw that was the very start, like read the proto, right? So we read the proto and then I start looking through it and I saw that there's, adders, right? So there's the adders. And then I saw right off the bat, I saw this thing called the rule implementation hash. And I was like, oh, what is this? And I was like, okay, I'll throw that in. Obviously to the calculation, it seems important. It's like hash, right? So we'll use that. But eventually I went back to that GitHub issue I'm referencing. Bazel, that's still open for actually asking for a feature like Bazel-Diff. And other engineers confirmed that key was required for that. So then took that, put it into my hash key. I use a message digest. So throw that in, throw in each attribute, loop through each of the attributes, throw that into my SHA. And then I go through my deps, everything that I depend on. And then I recursively call my hash function on that. And then I also go through each of my source files and I hash them, right? So all of those source files get hashed, all of the rules get hashed, and then we apply this recursively and we're done. So V1 was interesting. I was very attached to this concept of only passing in the modified file path. So it actually required that BazelDiff could not be launched if there was active changes in the tree. So like it had to be in like a clean commit. So you had to be like, it was a fine in CI because it'd be like, here's pre-merge, post-merge, right? Whatever. So it's like, check that out, run BazelDiff, check this out, run BazelDiff. They can compare the sets. And this modified file pass thing was kind of an unfortunate decision on my part because when I did modified file pass, I had to figure out which targets these file paths belong to, right? So I ran a Bazel query to see like what they belong to. And like, if I found that in anyone's set, I hashed that file and included it. Otherwise, nothing got hashed from the source list, right? Which is good. It was like a performance win because of that. But to make that work in a file delete, I had to pass keep going. So there's like keep going flags going on. And this usage of keep going to make it work actually took some value out of BazelDiff because people were using BazelDiff as like a front line to validate their build graph. This was an unknown use case for me. I'd assumed that the build graph would be validated and then Bazel. I got feedback that no, when I run BazelDiff, I need it to validate the build graph and fail. It can't give me like an Xcode 0 if the graph's invalid, which it would. So kind of went down this pathway for a while and it was, the modified file passing was working, was getting more inbound about like, please keep going is wrong. Xcode's bad, right? So I was like, okay. And one day I just ripped it out. Now we read every single source file, right? So we'll get to like, there's more issues with that, right? So every single source file gets hashed. So in the phase that we're in now, read every rule, hash this, recursively do the deps, and read every single source file and hash it. And yeah, it didn't have a huge performance hit with us, but we gave us a lot more confidence because we always know it's correct. It's like always correct. The modified file pass thing with the keep going, it was kind of making me concerned about kind of weird edge cases. And it also needed me to execute Git. So now like Git has been removed from BazelDiff. There's no more need for Git. It's just kind of closer to what I consider probably more Bazel-y a solution.
Right. So now it's just a matter of running it sort of like, yes, you're going to be on two different commits, but it's just basically two different points in time and there's no like coupling to actually to Git, right?
There's no coupling. Yeah. And yeah, exactly. You don't need, it's just like you do our CI, we just check out the previous commit. We have to run some preparation. We do some lots of code gen in our repositories to do that. And we run BazelDiff and then we check it out. Obviously post run our code gen BazelDiff.
Yeah. So really though, you'd be running it, I guess, against like the merge base would be like master or whatever, right? So you'd be comparing that commit against the PR commit, right?
Exactly. And then we actually even do it on our main branch. We actually do it. We didn't do this previously. So what we do is when we deployed this technology, it was dramatic. It had a dramatic effect on our speed and stability. So much so that main builds were taking, our queue now was full of main builds. So we just had a queue of these main builds because the main build still did Bazel test // as a validity of what was happening. And we did this for about a month and we never got a red. We never had, like, once the salt was, everything was kind of solid and BazelDiff was very reliable. It was, from iterating, finding these edge cases, we have not seen a red-green flip on main since this. So we then did the logic in main. So in main, we actually check out the previous commit on main and then this commit on main and do a diff on that. So that can kind of reduce that test time.
Yeah, that's great.
Yep.
Yeah, cool. Yeah, that's awesome. So maybe, I don't know if there's anything else to kind of dive a little deeper on in terms of like the implementation, like what's going on under the hood. So I actually, before we get there though, I do like the fact that we've already touched on the removal of Git is great. And then the removal of keep going also.
Yeah.
I know that was sort of one of the biggest issues I think that a lot of people had, was that it seemed like for some reason errors could slip through and cause issues. So I think that's definitely a welcome change. But yeah, so I guess, in terms of like the implementation for folks that might really want to hear a little bit more, I'm just trying to think if there's anything we want to deep dive on at all there. So I guess, like, how does the computation of the action hash, like, that you're doing, like, how is that different than like what Bazel itself might be doing internally? Because obviously, like, every action has its own fingerprint already, and that's how we're actually able to find these things in the remote cache, right? So like, I guess it's probably not true that like the action cache key for a given action that would be found in a remote cache would align with what's done locally, right? Because you're sort of recomputing that yourself. So what are your thoughts on that?
Yeah. So this is all stuff that it kind of touches on the fact that, like, you look at this problem space and you say, well, I run Bazel test, right? And I do /// Why do I need BazelDiff? And then you're kind of looking at that. It's like, well, it figured out what to do there. So it's kind of like BazelDiff is just doing something that I really believe that we touched back to. There's a linked GitHub issue to -- show rule key in Bazel, still open, been years. This key would do that. This key would say for every rule, I think it came from Buck, every rule it could say, here is, hey, I can just run this. And if I ran query, it would tell me the shot of a rule. And that is all we need. All we need is that ability. And we could just check out a commit, run query. Here's all the targets. Here's all the rule keys, right? Then do this. And then we're done. We have both the sets. What we're doing, we're just missing that lever, right? Like that lever. So we have to go and reverse engineer it using these protos. It's kind of like a bummer because it's obviously, we developed this out of band from Bazel. So it's like there's a Bazel upgrade and obviously we want that to work. But it'd be so much different if this was just a feature inside of Google. Like, think if they had a CI job as part of Bazel to say like, hey, here's all these rules. We just added an attribute. Like when we run the query with show rupee, none of them better, like, unless we added the new attribute, none of them should fail. This is like such a powerful feature to validate like everything you think happened is like legitimate. It's like, this shouldn't affect the implementation or this shouldn't affect this. Like, it's actually a very powerful system to tell you, have I mutated a rule? Has this change somehow mutated a rule that I did not expect it to do? I think that there's so much value even inside of Bazel for them developing it to maybe have this ability. I'm not saying they self-consume BazelDiff. I'm saying like they just provide that feature to themselves because obviously we have the information to figure this out.
It's just still, after all this time, not necessarily surfaced.
Yeah. And it has to be known, right? Like this has to be known at some level. This is the crux of Bazel. So in the absence of that, we're doing this. Yeah.
Oh, it's unfortunate. Is there any rationale behind like why this feature request can't be implemented? I don't know if there's any PRs around trying to implement it.
Did you have some conversations or something?
There is a lot of back and forth, I think, in that thread. I don't know it's the last update in there. This issue is kind of a little bit more aspirational. Like a lot of people talking about like how the solution works either at their company or like could work. And it's interesting, actually, there is some integration with some Google engineers about BazelDiff in terms of like checking it out and verifying that it seems kind of a sane way to like approach the problem. But, we're not seeing too much movement here. I think it's kind of turned into, there was a bug at one point. BazelDiff was affected by a bug in the rule implementation hash. In one version of Bazel, it was incorrect. So we kind of had to wait until that was fixed to even kind of rely on it. But there's not really been too much else happening.
Yeah. So, I agree that in theory, this is something that ideally could be a part of Bazel. We talk about all the time. It's like Bazel's missing a command, right? Like Bazel CI or something, right? Yeah, definitely. And so I think there's definitely some pressure from other folks in the community as well to maybe prioritize getting this fixed or implemented or solved in Skyframe.
Yes.
And I'm not a total expert on Skyframe itself because I haven't worked on it too much, but I think really the problem probably lies in the incrementality model. They talk about bottom up invalidation versus top down, and really they only support bottom up. And I think that might be part of like the limitation right now is that if there's a bit more top down support, maybe that's kind of the missing piece here. I haven't like done a deep dive in that in a while though. I think that would be ideal because I think that the other challenge with a tool like this, obviously, is like there's a considerable amount of like additional infrastructure and scripting around it, right? I mean, what we're talking about is like reading every file in the code base,
Yes.
right? Like this would take dozens of hours at scale, right? For each patient, I guess, right? So like maybe let's talk a little bit about how folks deploying the solution as is at scale, like would go about operationalizing that.
Yeah, so we are fortunate that, we're not like a Google level tech company. So this hashing sources thing hasn't hit us too hard. We definitely get inbound about, this thing's trying to read a use cases. I just didn't intend like 20 gigabyte file, right? I'm trying to read a 20 gigabyte file and hash it, right? And so the nice thing about that is the community's come in and helped out with some of that. And the community's coming in and helping out the hashing speed. And we're looking for more speed in the hashing. Self-admittedly, I'm not a Java expert. I know some about Java, but I don't know like low level. How can we do some cool things? And luckily for me, there's active people in the community coming to help. So there's that part of it. How do we actually run this at a massive company? And then there's another part of it is you're running this basically command twice every time in a PR. Well, at least we are, right? So we are saying, hey, essentially read all the files and calculate Merkle trees for everything, and then create this JSON payload. Do the same thing on the second revision. I'd really advise anyone trying to deploy this technology to not do that, and instead, from the beginning, just create a server, right? So create a server that runs this technology and communicate with that server and say like, hey, some build kite agent, right? Like maybe that job runs first. It says, I'm going to actually, that pipeline's result is the affected targets. I'm just going to give you that to the next job. But why that's valuable if it's another service is you already know the answer for one of the revisions, right? That's kind of the great thing about the solution. You only really need to do it once for each time. And that you're taking half the amount of reads out, right? So it's like, that's a great, way less reads is going to be always better. And I really suggest anyone doing that. And I think that kind of comes into some of the early feedback we got, which like there's some people from Google were pushing for, or inbound people from different rule sets were saying, oh, can we Dockerize this? Can we create this into a service? And that is a great idea. I love that idea. The issue is that we actually do, sometimes companies need to do things before BazelDiff runs, right? And so that was one thing we couldn't abstract well beyond is saying, oh, like we actually run 3 commands. They're kind of like these setup commands before we run BazelDiff. It like sets up our world for us. So it's like hard to bake that into a distributable artifact. And so like the best thing we do for the community is provide this example script, which you can just like run easily on your Bazel repo. And it's like, cool, it did something. But every company is different. We can't say like, oh, you have a clean slate. And so you can run this like Dockerized service and then it'll always be correct. It's like, you may need to run a couple different things. Who knows? I'm not sure what your setup is. Maybe you have a bootstrapping that needs to like set certain things up locally. So it's kind of hard to fix that for everybody.
Right. Yeah, it makes sense. Cool. So yeah, the example script, I'm actually taking a quick look at it in real time here just to remind myself kind of what the steps are. Okay. Yeah. So, I mean, it's just kind of like generating basically the 2 different invocations of the thing, right? That's sort of I gotcha.
And so, I mean, if you just take that, that's a place to start. But yeah, if you throw that in your main CI pipeline and you have a Google scale level repository, it just won't work. You can't just read all files twice, So yeah.
Mm-hmm. Yeah, this is definitely, it's good enough for an example, but it's scale. It couldn't really work either. I mean, we love the idea of operationalizing this as a server as well. It's something we've even talked about, like, does it make sense for us to try to contribute something here, from the Flare side? But yeah, you're right that like it is kind of hard to say like how do we support every use case, right? Yeah, that's a definite challenge. So I guess if we imagine if you did implement a server, at least something to meet your own internal use case, which I'm guessing you guys probably already have done. In your case, I guess like so the final output is what? It's a JSON file or something, correct?
Yeah, essentially, we just need that JSON file and then the actual normal Bazel-Diff command. I mean, it's doing something if you're writing some shell, but it's just doing the diff of these two sets of JSONs and just telling you which targets are impacted. So then you take that for us, again, each use case is different. So you could take that and just be like, hey, I'm going to actually put that in. Some companies like, hey, put this in like an artifact to say, like, if I look back, I can say these are the targets that changed because of this change. For us, we just run an RDEPs, obviously, on that, and we do an RDEPs for our tests. And so it grabs all our tests and we execute them.
Yeah.
Yeah.
I assume people might want to use RDEPs over the binaries with those changed inputs as well.
Yeah.
Potentially.
Yeah, exactly. Yep.
That part of the process is fairly similar to like what people would have seen, like just using a little bash script maybe, except for it's just the way we arrived at that set of files is of course very different.
They're very different. Yeah. Like touching on Benjamin's talk, each of these queries can have a different manner of expressing paths, so it really does come to this thing of kind of just a rubber band ball kind of solution where you're just kind of like growing and growing. It's like, oh, run this query in this, like, oh, well, this kind of query returns a different path to that file. And then you have to like remap that to something else. And it's like, oh, but the file's deleted. Like, oh, let's make sure the BZL file wasn't first. And you're like, so again, it's at the end of the day, you have to pick your poison. BazelDiff is going to be slower. If you have a massive repository, right? Like it's going to be slower. But for us, we've personally seen it to be at our size, it's been perfect. Like we have not had a red to green flip since we deployed this technology. Whereas, you could run query and it can be right almost all the time, right? Like almost all the time, I feel like query can't be right. It's like a decision. But again, really, we shouldn't be making either of these decisions because I really believe that, we should just be able to tell Bazel and like, hey, tell me, what's up, right? Like tell me what the state of the world is right now. Yeah.
Well, it's a tough challenge because Bazel obviously doesn't have any assumption about a version control system, for example. So I think that's where the challenge can come in.
Yeah. It knows where it is now, though, right? Like, and that's all we really need. We need it to know where it is now, and we need to know where it is. Whatever your version client is, you check out some other or whatever they all call it, different version clients. Check out a different revision. Tell me, Bazel, what you think the world is right now, right? Like, tell me fully. So, yeah.
Right. Gotcha. Cool. So I guess something I've been thinking about recently. So obviously in Bazel, there's some newer flags around using a target pattern file. Obviously, there's been the query file support for a while. I guess what are your thoughts on with some of these newer additions that make it so, like at least it's in theory, it's possible to pass many thousands of files into Bazel now. Finally, targets rather. What are your thoughts on implementing this just in a bash script today with the newer tools? Is this something you think that you would pursue differently now, given that there's at least a few more flags to help you out with this kind of stuff?
Yeah, so I hit these max args things very quickly because when I developed BazelDiff, I generated a 30,000 module Swift code base to test on. And so I would edit one file and then run BazelDiff on it. And immediately, obviously, ran tons of problems. One of them being max args. Right. So you hit max args to query because you're feeding it thousands and thousands and thousands of targets. So query file was a must. We had to use -- query file to do anything. For, target file pattern, that is more on our consumers. I think we have potentially an avenue still today at Tinder where you could pass too many args to, Bazel test, because of the fact that we're just not Google scale. We haven't hit that yet where we're like, hey, we need to pass another file representing all of these targets. But yeah, I would advise anyone doing queries or potentially actions with any computation, even if you're doing a query attempt and you want to avoid BazelDiff, definitely lean into query file and -- target file pattern because, when this breaks, you really have to hustle to fix it. We had a situation where we reset a bunch of files and it overwhelmed. We still had one query in our CI system, wasn't BazelDiff, but one query that wasn't using query file. And it was like we had to hustle and immediately get that working with a query file because it was literally blocking the team on this one PR. Lean into those right away. Just use them because the guarantee of never having to revisit too many parameters is like so valuable. And it's really valuable just to have one API. If you are creating abstractions of like how you use query or how you invoke targets, I just recommend using that for everything. It's worked very well for us.
Cool. Yeah. So I guess I'm curious with the existing implementation of the tool, like, are there any sort of big known issues or gotchas that kind of concern you that you hope that will get resolved at some point? Or what do you say the current state is?
Yeah. So one of the things that was going on when I first wrote the tool was cQuery wasn't really fully baked yet. So cQuery, when this was being written, didn't have all of the capabilities that query had. I don't remember exactly kind of what, but I remember I just avoided it. I just went to straight query. This has caused problems though, because we have teams that need to use configurations, transitions, and have BazelDiff detect that. I think one of my next steps is to rip out query and use cQuery everywhere and make sure that that works. And cQuery would be nice because we've had the community add capability of like adding flags to the Bazel invocations themselves that we use. And so then that just works because you could say like dash config, my special config. And now with cQuery, it's actually going to perform the configuration into the queries. So that needs to be fixed. That's like a known gotcha. That needs to be fixed. Other gotchas are, we just landed fixes for large file support, but, on truly like astoundingly large repositories, these queries can be expensive, right? Like that's just like the nature of the beast. I would definitely say that's like a gotcha. Some of these queries, depending on your repo, can take a while, right? And for us, this luckily isn't a problem. We don't have that many targets like that, but be aware of that. And again, I'm open for any kind of optimizations the community has around this. And then also files, like we're going to read a lot of files. So if there's a lot of files like in your rules and all these things, like we're looking actively for ways to optimize this, make this better. But yeah, it's an IO heavy operation. I'm not sure if I want to revisit the idea of like input files because I really do like the solution of like it's always accurate without needing any kind of like, hey, I know this file was changed, but we may need to revisit that as like maybe an optional pathway to get companies onto this. Because like otherwise, if you just have that many files, this is never going to work. It's capable to read tons and tons of files. And again, we developed this open source, but even myself, I'm learning every day about like new potential repository systems, right? Like that, and so that's been kind of interesting to see too.
Yeah. So another thing that I actually meant to already drill a little deeper on and kind of forgot when we were talking about the implementation details, but let's circle back one more time there. So obviously, another thing that maybe even didn't exist, well, it existed, but in a different, less obvious form when you started was a query, right? So this is a way to directly query the action graph. And in theory, the values that we care about might exist there, right? For example, there might be like literally action keys and things that we might use. So I guess I'm curious, like, if you looked into that. I sorry, I already know the answer here, but so maybe explain to us, like, why using something like aQuery also doesn't necessarily do the same thing that BazelDiff does here.
Well, aQuery would just give you the result of every action, right? So it's the action key, right? Or the action hash, right? Mm-hmm. But that wouldn't give you, like, if I change a file, does aQuery get changed? I don't like that.
It doesn't. Yeah, it actually doesn't. That's the kind of the critical blocker is
exactly.
Yeah. So its digest would only change if like the actual set of maybe inputs or configurations changed. But if the contents of those inputs change, it doesn't actually affect it, right? So that's sort of the challenge. So, maybe if there was a way for aQuery, and I don't know enough about the implementation details there either to know if this is even feasible, but like if aQuery actually showed like an action cache key that was the same as the one the remote cache client would be using, which actually does encode all of the changes to all of the inputs, then BazelDiff might be out of a job, right? But unfortunately, there's no way for us to get at that info very easily. Might seem like aQuery and BazelDiff are the same thing, but really not, because when we talk about action keys, we're really talking about BazelDiff is encoding the actual contents of the file, so that's why it's so expensive. Whereas, otherwise are not going to include that from Bazel itself, right?
Yeah, and I want to be clear. Yeah, it's like I'm fine with BazelDiff being out of a job. If this is part of Bazel and we have a flag, I'm down for it because I trust, I know how robust Bazel's CI platform is and how many things they need to test across. It would make me quite happy if this was just a flag. So yeah.
So basically, we had a question about the future of your tool. I guess like the answer is like you would like it to be like a flag and stuff.
Absolutely. I feel like it's been really awesome to meet so many people from the community and to learn more about different repositories and different use cases. It's been awesome to see that people have been easily able to use the tool. But it is a very interesting library because unlike anything I've ever made, I've always asked myself while working on it, like, why? Kind of like sometimes I'm looking at it and I'm like, why am I doing this? It seems odd, right? It just seems odd that I have to kind of devise what these values are. I would love to be at hopefully BazelConf this year or whatever, the next BazelConf, and hopefully speak more with engineers about like maybe why my assumption there is like off of like why Bazel wouldn't just know this or has an ability in Quarry to maybe check. I don't know. It's like, what would be the result? What would be the result with the contents of these files, change or something? I'm not sure. So we'll see. And hopefully maybe I can grow my understanding of like why Bazel can't readily support this.
Yeah. Well, you've written in Java, so you're halfway there.
That was very strategic.
The best Java Swift developer could figure out. So, yeah.
Excellent. I'm curious, do you have any performance estimation work done at all? So like maybe we could say, okay, well, for the Tinder repo, this takes 10 minutes. And maybe we could use that to ballpark, like what would it look like for like another, maybe a much larger repo to adopt? Like, is there any sort of metrics like that someone might use to figure out if this is like a workable solution for their repo without going to the challenge of actually setting it up and trying to invoke it?
Yeah, for Tinder, this takes probably 30 seconds for both the invocations to run. But again, this is only operating currently in our main iOS repository, so we don't have it operational in like backends or deployed maybe with more targets somewhere. So for an app I feel like an iOS app of considerable size, I feel like the performance impact if you're using Bazel is pretty negligible. I know that other engineers are at some other large iOS apps are using it in CD. So hopefully the performance isn't too onerous there. But yeah, I'm trying to think like, if you're in this massive data set, I don't have a lot of people reaching out yet and saying like, I have a truly astoundingly large repo and like, this can't work. I just don't have too much inbound yet. The tool is getting more visibility and more interest, but hopefully we can look at that and then develop maybe even some tests, develop our own kind of test suite there of like saying, hey, we shouldn't regress. Let's just code gen a repository of X size, run BazelDiff. We have certain guarantees of performance. Like you shouldn't be getting over a minute for 100,000 targets in Java, right? Like code generate. And I think that's a great, stuff like that would just keep us honest around just knowing what the profile is. Yeah.
Yeah, it's a great idea. Yeah, I had the same thoughts. Cool. I guess another kind of thought I've had is like, architecturally, what kind of changes might need to be made to support like kind of sharding up the work and running, maybe multiple jobs in parallel, right? Where we might have 10 different invocations or something running sort of in parallel so we can kind of distribute this work maybe across like a build farm or something like that.
Yeah, I think there's already a contributor reaching out to the repository that wants to already split up because currently we run everything serially, right? So we run the queries and then we run our reads, right? But like once we get our query back, we're good. IO reads can just begin like in a different pathway as we like generate hashes. One is like CPU bound and one is like more IO bound. So like splitting those out could like also unlock us some performance wins. But yeah, I haven't architecturally thought too much yet of saying how could we just pull off this first query across like a farm. Like, it's like this first query is just so hard, maybe because we can only have, at the end of the day, we can only have one Bazel process running per box. We can't run Bazel multiple times. So yeah, the problem is we do need the universe, right? Like at the end of the day, we need the universe, right? And we need to know everything because unfortunately, anything could have happened, right? So I could have changed an external dependency. I could have done this. I could have done that, right? We need everything to determine hashes, right? You even need the SHAs from your external targets to know if those changed, because you could have updated a library. Now it's going to, all these are going to be validated. I guess I haven't thought too much yet of like, how can we break up the universe query?
Yeah. Well, so actually something that comes to mind is the Bazel idea plugin. They do have some sharding going on in there where they actually do invoke, like literally invoke multiple, kind of sharded builds or whatever. So I have to think a little bit more about how that works. I know that that's relying on if you actually have remote execution running, because obviously trying to do all that locally would be a challenge. I guess they have some mechanism for firing that up. And I don't want to talk too much about it because I don't actually remember the implementation details. I don't want to get it completely wrong. But there's actually a semi-public slideshow floating around somewhere that some folks on the Google team working on that actually put together for the community. And it talks a little bit about that part of this, like, the Bazel sync phase. And they do talk a little bit about the sharding. So that's something I'm actually trying to find a link on here. I seem to have lost it. But in theory, maybe there is a way. Maybe we can take a look at what they're doing under the hood there. And maybe that can kind of inform like some parallelization effort on BazelDiff itself. Okay, well, yeah, this has been great. A lot of awesome info, and the ideal end state would certainly be having this natively just live as part of Bazel, but yeah, it doesn't really seem like it's coming anytime soon.
Yeah, I'm subscribed to the issue and we'll see. But, anyone out there it wants to contribute, we're welcoming, any and all contributions. And I feel like it's a great tool if you're invested in Bazel. You can learn a lot about kind of how Bazel works and how Bazel's calculation of what's changed could be implemented. And I think it's been a great learning experience for myself. So if you want to help, I'm sure there'll be a link to the GitHub and we'd love to meet you there. So
yeah, that's great. On that topic, are there any like current existing sort of like feature requests or roadmap items that come to mind now that people might be inspired to jump on?
Yeah, I think top of mind, like I said, is C-query support. I think that's a number one. And I think it's a great first issue because the way, the code is written, that should be a pretty easy entry point into making a change and writing the test. Beyond that, anyone with good understanding of how to really optimize Java file reads and like how to make that as parallel and as performant as possible, that's a really lacking thing that I just never really learned a lot about. So I would love any Java experts, but really any contribution, I definitely welcome. And the Tinder org welcomes. And, we want to see how you use this tool and we want to help make it better for everyone. So, yeah.
That's great. Awesome. All right. Well, I think that about covers off everything that I had on my agenda.
Yeah, I think we covered everything. If you want to throw your contact details or any announcements you want to make, except for like obviously contributions?
Contributions, yeah. I mean, that'd probably be the biggest thing. A link to obviously BazelDiff. My contact info is maxwellelliott@gotinder.com. And if you have any questions, just reach out to me. People like Benjamin helped me out a ton with learning this, and I would love to help anyone else who's trying to learn the same kind of stuff, or maybe you have a way to do this even better than Bazel did. And I would love to help. So, yeah.
All right.
Yeah, that's
awesome.
amazing. Thank you so much.
Thanks a lot.
Thank you.
Thank you for tuning in to the Flare Build podcast. Please like, subscribe, and tune in again with Zach and Tatiana for the next podcast in the series.